Hello. Hi, everyone. Yes, good that you are all are in the appropriate attire. All are having the lab coat, shoes on. Yeah, it's great, 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 good, very good. But next lab, I am there. This time, hopefully, everything will be fine. So I am there next lab. First of all, have you submitted your lab safety form acknowledgement through Canvas? But I cannot see why. I was checking yesterday. I did not see any of you have submitted. So probably, can you send me through my email as well? I don't know what's wrong with my I don't know what is the wrong with the Canvas, but it was open until 19th of March, supposed to be submitted by 19. I think many students have submitted, but I cannot see. So please send it to me through the email so that I can compile and if possible, I will upload it for you guys. Okay. Next thing is you already have seen the assignment given to you. So one student just said that his group member is same as the lab group. Somebody said to me, I think Kishwan. Kishwan, yeah, yeah. He said, who is Kishwan here? Is there in the lab? No. Kishwan. June. Oh, he's in online. Anyway, so he said that his group member for assigned group is same with the lab member. One lab member should be okay, but not all. That's why I randomly choose because you did not send me the name. Only one group sent me the name. So the other groups I randomly choose because it was supposed to be done by yesterday, so I had to do it. All right, now the third thing is the Experiment 2, investigating chemical reactions. So as we have just started the chemical what is the yeah we have started chemical bonding, and inevitably the chemical reaction will come along with the chemical bonding. Just after chemical bonding, we will learn about the chemical reaction as well in the lecture. So the our main goal to learn the chemistry or to chemical knowledge to know what will be the product. Okay, what will be the product or how we can get that product. And then by knowing that we will get this product or that product, but how do we make sure that we have gotten that product? What if it is a mistake and we do not know how to know this is the product, but it was a mistake, then everything will be, let's say it's a food or it's a medicine, and we knew that we are making the medicine A, but in turn that it was medicine X, and it was, of course, nobody will go to take that medicine. So for quality control, for production, for optimization, for identity of the chemical, we should know the chemical reaction. And for this experiment specifically, we will be using a lot of different type of chemicals, solid and liquid, that means solid and solution both, right? And we will also be using the Bunsen burner. Be careful of treating the chemicals today. Okay, can you hear? I repeat, be careful of treating the chemicals today. Consider all the chemicals are hazardous. All right? Do not even trust the water inside the lab. I mean, trust means do not drink, even if it says that the distilled water. So, because you never know that it may be contaminated or not. So do not try, treat all the chemicals and hazardous. Use the, the chamber, what is the chamber name? The blower. What is the name of the blower that you call? Shahira, what do we call that the chamber that we do and the glass sachet? Fume hood, sorry, yeah. So you will be seeing that the chemicals are in the fume hood. So do your experiment in the fume hood. Do not bring the chemical out of the fume hood. Today experiment, very careful, please. Okay. So there are many things that, I mean, you can go through all these things later on. So what we'll be doing is we will see the color of the solid solution and also the aqueous solution. So solid solution like copper is blue, but sometimes there will be copper, it looks like white. And sometimes there will be copper, it looks like green. So due to the different valencies, uh, you know, I'm that guy. So who is the Ainin, right? Yeah, Ainin. Why copper has different type of valencies? Any idea? I'm not asking you to be correct. Any idea why copper has different type of valencies, +2, +1, like that? Yeah. Simple answer is it is transition metal. It has d block element, so they have variable valencies. All right. So due to the variable valencies, d block element, their appearance changes. Of course, with hydroxide, with oxygen, with the nitrogen, if they're attached to nitrate group, their color will be changed. The same iron here, you will see that a very pale green, but then another iron, Fe3, it will be orange to yellowish color. So it is very interesting thing that why it is changing. And for your assignment, uh, uh, I mean, are you following what I'm saying? Okay. Do you have the manual with you? Yeah. So I am on the manual. I am at page number, well, second page of the experiment 2, chemical investigation. All right, colors of ions in aqueous solution. Okay, so that I was telling that the changes in color of the different ions, mostly the color for the transition element, the color will be changed. So this is interesting thing. You will need this information for your assignment as well. For assignment 1, why and how they combine to different elements, why they are in such arrangement, and then why they are having different colors, how do they behave in magnetic field, whether they behave in paramagnetic way, magnetic way, the vibrational thing, all those things, it will be important for you to know. So far, if you cannot follow where I am, or if you have any question, please let me know so that I can clarify it. Anyone? No. Okay, good. Not good. I mean, I can proceed. That means good means that you already, I mean, you talk to me. That's the good thing. But if you have question, that is even better. Okay, so neutralization reaction. First of all, we will see the color. You just have to note down the color. You see the Doris has already prepared it on the table, the solid and liquid chemicals, and then there will be neutralization reaction. All right. So how does it get neutralized when we add acid and base together? How much does it need to be added? to get it neutralized. And this is a simple reaction, and we know all these things very good. We can use the litmus paper to know whether it has been neutralized already. If it is, the paper turned to red, it is in acidic form. If it turns to blue, it is in basic or alkaline form. And if it is not turned or does not change, that means it is neutralized. All right, so after this, we will go to the thermal decomposition reaction. Thermal decomposition means the solid chemical, not liquid, when it is getting decomposed in presence of very high heat. Decompose means they will be separated, they will be dissociated, something will be eliminated from that sample and something will remain in the solid. Of course, the color may be changed, the volume will be changed, the smell may be changed, but they will be decomposed in presence of high heat. Now, material don't only decompose at high heat, they can be decomposed in presence of UV light as well, but we are not going to do it here. All right. Okay, so I go directly to the report, the report, the aim, the results are here. So you will need to write magnesium chloride tetrahydrate. Are you following where I am? It is page 141 of the whole report, but probably it is I don't know, fifth pages. 1, 2, 3, 4. Yeah, fifth page on your report or page number 141, right? So here, color of solids and their solutions, you will see that what is the color? Magnesium chloride, and it has 4 water molecule in it. So tetrahydrate. Ferrous sulfate, heptahydrate, 7 hydroxy, water means hepta. Cobalt chloride, hexahydrate. So these are the solid, and if we dissolve in water, they will change color. And you have to come up with the idea that what is the ion that is representing the changes in color for this type of chemicals. In the discussion, you can also come up that if there were no water, like tetrahydrate, heptahydrate, anything, if there were nothing, then how would they look like? What would the color be for them? Okay, so this is in the discussion you can do. The second part is hydrolysis of salts and pH of solution. Hydrolysis of salt means in water, how do the salt get dissociated in the water? We know that salts are formed when there is a reaction between acid and base, right? Acid and base, the salt will be formed, and salts, all type of salts are very good electrolyte. So in presence of water, salt will be dissociated fully. We will be studying this in the next week lecture. So after you do it today, hold on. I don't know who is it. After you do it today, then in the next lecture, when we go and talk, it will be clearer for you, I hope, and it works that way so far. So the salts, when we dissolve in water, like CH3COONA, the first one, sodium acetate, we dissolve in water and it will be dissociated and they will form sodium ion and acetate ion. All salt will be dissociated in water. And then they will form a charged ions. Like for example, the first one, group A, CH3COONA, this is sodium acetate. So it will be sodium plus and CH3COO, that is acetate negative, in this way. But one thing is, depends from which acid or base the salt is coming from, they will be tend to become acidic or basic. If it is coming from strong acid, they will form a basic type of salt. If they're coming from strong base, they will form the otherwise. So we will be learning this thing as well. So based on this structure or from this idea, we will know what type of salt or what type of solution this salt is producing. And to know that, we will use indicator. And for this type, we will be using universal indicator. Doris should have provided you with that indicator and that strips that we dip it inside the solution, and we will see the color changes, and according to that color we match it against the level on the strip file or box to know what is the pH of it. Shahira, do you have any of that in front of you with you? The universal indicator nearby? Okay, she brings it by the time we move on. So sodium chloride, for example, sodium and chloride, it is, yes, hold on. So you take one strip, put it inside the solution, and then you see what is the color changes of that strip, and then match it against the color leveled on the box. So you know what is the pH of that solution. You will not get exact, but you will get a range, and then you will get an idea of what will be the pH or what might be the pH of the solution. For example, I was going to talk about the sodium chloride, that is the group B, that is in group B, sodium chloride. Sodium chloride, can anybody tell me where this salt is coming from, sodium chloride, but what reaction? Does anybody want to be volunteer? Where this sodium chloride is coming from? The salt is prepared by reacting what? Two things will be reacting, then produce sodium chloride. What is the reaction? I know this is Ainin. Who is in the middle? You are on mask, so I do not know. Yeah, I already have seen you. Cannot run away. Who is it? Your name? What? Audrey. Audrey. Oh, you were Audrey. Okay, hi. Yeah, so any idea from where that salt sodium chloride will be prepared from? I think you are stressed, but it is simple. Sodium hydroxide and HCl. If we mix together, the sodium chloride will be prepared, right? Sodium hydroxide, NaOH plus HCl will produce NaCl. So from that reaction, we see sodium hydroxide, NaOH, right, and HCl, both are strong acid and strong base. So this salt, sodium chloride, is coming from a very strong acid and very strong base. So by definition, they are neutral. So you will see that this salt, it is being dissociated in the water, producing sodium and chloride, and they are giving you a pH of around 7. If you do not get pH of around 7, then probably your sample is wrong, your solution is wrong, or you have something on your test strips. Otherwise, always, you do it in Malaysia, in India, in US, everywhere you will get a pH of around 7, neutral pH of that solution. So this is how we will do the hydrolysis solution and pH of the solution. Precipitation reaction. So for the precipitation reaction, there are two parts, and the formation and dissociation of precipitates, it will follow. But for the precipitation reaction, silver nitrate and sodium carbonate, if we mix together, Okay, 0.1 milliliter, 0.1 molar and 0.1 molar both. So this initial reagent, you will be using 0.5 milliliter. That means around 3 to 4 drops. All right, I'm going to number 3, precipitation reaction. Silver nitrate, we will be using 0.5 milliliter, that means 4 drops of it. And then we will be using that sodium carbonate, 1 drop or maybe 2 drops. If the whitish precipitate silver carbonate does not occur, then what we'll do is we will be adding one drop of HCl or maybe another 1 drop, not more than that. But when you are using this HCl, be careful because it is 10 molar HCl, right? It is 10 molar HCl and it is very strong and it is very corrosive. Be very, very careful. Even if you are having the nitrile gloves, it may penetrate. Be very careful when you're using it. Do not take it out of the fume hood. And when you open the bottle of HCl, please turn on the fume hood, the fan in the fume hood, so that the fumes will go out. Otherwise, do not inhale any smoke or any fume today. It is very dangerous. I mean, not very dangerous, but inhaling is dangerous. Okay, so in the yeah, any question, anybody? No. Okay, good. So now we move on. Move along like this. So now we will be adding silver nitrate and sodium chloride, silver nitrate and sodium phosphate, silver nitrate, potassium carbon dichromate, K2CrO4, potassium chromate, in fact. So all these things we will be adding, and we will observe what type of precipitate is being forming. And then the most important thing is 2 things here, that you write what type of precipitate form. Do not try to copy your friend. You do not know what type of precipitate form. I know. So if your friend say, oh, it is white, oh, it's black, it's gray, and you just copy, and you are getting it wrong as well. So if you are getting white, just write white. If you're getting black, So if you even make mistake, if even it is a mistake, you are satisfied that the mistake is by yourself, not by copying other. All right. So yeah, that is the thing. Sometimes students just copy looking at their friends, but all of them are wrong. So just look at what you got. And then the important thing is ionic equation. Write down the ionic equation. All right, of that reaction. Now, another thing, number 4, formation and dissolution of precipitates. We know that precipitate from this table, precipitation reaction, the precipitate is being formed, white, black, gray, yellowish color, all those type, brown, different type of precipitate will be formed. But how do we dissolute or dissolve that type of precipitate? In what reaction, or we add what that it will dissolve the precipitate? For example, sodium nitrate, silver nitrate and sodium carbonate. If we react together, there will be a white precipitate of silver carbonate. Okay, silver carbonate will produce a white precipitate because this silver nitrate and sodium carbonate reacting together, silver carbonate is being formed. And why this type of reaction is occurring? Both are salt. Why this type of reaction is occurring? You can also discuss in your discussion later on. So then you have to separate in 4 different test tubes. Test tube equation 2, equation 3, equation 5, equation 7. These 4 different test tubes you have to separate. It is very hard to separate from where you precipitate. So what you do is you prepare 4 test tube, add silver nitrate and sodium carbonate all together. So in this test tube, you add the silver nitrate and sodium carbonate. Again, you take another test tube, you take silver nitrate and sodium carbonate. Again, another one, take silver nitrate, sodium carbonate. So you prepare 4. And then in that 4 test tube, you keep adding nitric acid, and then you add lead nitrate. In another one, you add sodium hydroxide and see how's the changes. All right. How is the changes? And later on, you have to explain all these equation 1, equation 2, 3, 4, 5, 6, all these equation, write down what is happening, how the reaction is occurring between all those things, how the metal, I mean, ion exchange is occurring, all those things you write in the discussion in thing. Neutralization reaction, I don't need to talk much. Neutralize means acid and base will react together and it will be neutralized. So it is not, to me, it is not very important thing. Only the important thing is gentle warming. It does not always, the information we get from this gentle warming is even though acid and base alkali is reacting, they are not readily, not all the time, readily neutralizing each other. Sometimes you need an external factor. The external factor for this case is heat, not very high heat, a little bit of heat. So number 6, evolution of gases. All right. Evolution of gases, we have only one. I think we have only one or two. So hold on, I have forgotten which one, but you, Shahira, later on, please see which one Doris has prepared. I'm sure that we do not have all three. We have only one or two to provide to the students, because probably these ones, sodium carbonate and sulfuric acid, this one. So when sodium carbonate and sulfuric acid are added together, and you have to, after we mix together, you put in the water bath. The water bath will be around 60 degrees centigrade. So put it inside and then cover it. If you are keeping the test tube cover, be careful because the gas can make it pop. The cover, it will pop up. So be careful of your eyes. All right. All right. So this is one, and the same thing goes. So when you want to feel the odor of the gas that is being evolving, do not sniff it like this. Don't do that. It's dangerous. So what you can do is take the test tube here. If you are really do not get the odor yet, mostly you will get the odor. What type of odor is a strong odor? But if you do not get, just keep this. Can you see? You can keep the test tube here and then wave in your hand in this way. So a little bit, a fraction of the odor comes to your nose. All right, like this. Do not sniff like this. Don't. It's dangerous. And then it will be, and this will be interesting thing. Where is it? It will be very interesting thing for you because every of us has different perception, different sensory capability, different understanding of sense, different tests. So you will see that different people, different students is telling is different order. Strong, not strong, sweet, sour. So yeah, it will be different based on the subject. 7 is metal replacement. Copper, if we put the copper sulfate and zinc metal in copper sulfate, we take 5 milliliter, I mean half of the, not half, like 1/3 test tube fill up with copper sulfate. 1/3 of a test tube filled up in copper sulfate, and then put a small metal of zinc inside. You see what is happening. Is it a fire occurring? Is it a gas or whatever? I'm not telling you exactly what will happen. You have to know. You will have to do the observation. And at the end, what type of ionic equation are involved in this reaction? Okay. Thermal decomposition. Is there anything else? No, this is the last one. Thermal decomposition. We have only one thing here. Lead nitrate. Mercury oxide is very dangerous, so we do not provide mercury oxide to the student. And only lead nitrate. Lead nitrate is a white color powder, solid. So we take in a test tube, we take this much, small amount, like how many, Shahira, we did it last time. So do you still remember how much do we take? This thing is important and it's dangerous. Yeah, we take a little bit, like a little bit at the bottom in a test tube. Just hold on 1 second, yeah. Sorry. So for this thermal decomposition, what will happen is when lead nitrate, we take a little bit of lead nitrate, a little bit at the bottom of a test tube. But when you take the test tube, make sure that this test tube is Pyrex test tube. All right, borosilicate Pyrex test tube. In a normal test tube, if you put it on the heat, I mean naked flame, so we take a little bit at the bottom of a test tube, all right, a little bit, and then put it on a heat. Like, okay, this is a flame. We hold it like this, a bit inclined, not directly on top. Hold still not directly up, a bit tilted like this. Okay, but do not point to anyone's face or anyone's body. Point away from other student. And then on the flame, we put it on the test tube, put it on the flame, and you will see that after some time, the gas is coming out, brownish color gas is coming out. And in that gas, if we put a string, the string are the thread, very thick thread, like a this type of thread. Okay, this is my charging cable. The threads are like this, cotton thread. We burn it first. We burn the thread first and then put out the flame, but still there is fire in the flame. I mean, in the thread at the end, and then we put it inside the mouth, the opening of the test tube. So you will see that the fire is like glowing, becoming bigger because of some gas coming out from the test tube. All right. So some gas is coming out from the test tube. So that will ensure that what type of gas is coming out. And if we put a litmus paper, green or red litmus paper, we just make it a moist, a little bit. Do not make it wet. Just make it a moist, the litmus paper, and put it on at the mouth of the test tube, at the opening of the test tube, and you'll see that the color is changing or not changing. Okay, so that will confirm the presence of certain type of gas, what is happening at the lead nitrate. And when you heat it, it will be a sound. Do not hold still the test tube. Make it a bit gentle moving, not very fast like this, but gentle moving, so that heat is dissipated or dispersed everywhere where the sample is. You will see a cracking sound, sound when there is a heat, when you are holding the test tube on this, but don't be scared. But just make sure that it is not pointed to anyone's face. Otherwise, it may jump and then it burn. So be careful in that. All right. So yeah, this is it. This experiment is lengthy. It's not that difficult to do. It's very easy to do. Time consuming, one thing. Second thing is the report. The report needs to be very detailed of what you are doing, why it is happening, how it is happening, why it is not happening, like that. So be careful today for the experiment. Once again, I remind you that it will be all the chemicals you will be using today for handling. So yeah, all the best to you. How many students are now there? Hi, Veron. Great to see you. 6, 10. 10. Oh, great, great. Thank you, Veron. Thank you. Great. Thanks a lot. Yes. So you guys can go, but one thing, when one group is doing one part, don't go and mess around that group. You can go and do other part. Okay? Don't wait for him to finish and then you only do, but you are not doing, you are sitting. No, 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 don't do that. Your friend is, another group is doing one part, you go and do another part. It is not linked. You can do separate parts. Audrey, you want to say anything? I cannot hear you.
Many people per group.
I cannot hear. Can you turn off the micro Bluetooth?
How many people per group?
3 people per group. 3 people. One is left, yeah. So 3, 3, and 2, 2. 3, 3, 2, 2. They should already have the group.
Her left partner is online.
Sorry?
Left partner is online. John.
Oh, yeah. I am grouped with Audrey, sir, but I am online. Okay. So, Audrey, you will go to one group. So, you and another one, 2 of you will form a group. And please share the data. Share the data with Sean later on. Okay. Yes, please. Thank you. Thank you. So 3, 3, 2, 2. All right. Okay. Hello, can you hear me? Okay, so 3, 3, 2, 2. Just faster, do it faster. Otherwise, it will be late. And after 4, Doris will just close the door. Doris will be here at 2:30. She told me that she has a meeting. She will be here at 2:30. So from 2:30 on, she will be there. But please handle it before for half an hour more.
Do we need to follow from the last lab one?
I cannot quite hear you, Ainin. Yeah?
Last lab one.
Sorry, I couldn't really hear. Couldn't really hear.
Do we need to follow last sem one? Last lab one.
Yeah. Yes, you can follow, or if you want to make a new group, you can make a new group, no problem. What is that? I think it is easier for you to follow the previous group. It will be faster. Okay, so I want you to start in.
Oh, I see.
Shahira,
You don't listen.
I want them to start in another 5 minutes. Settle the group. Huh? Faster, start.
You got 2 hours and 5 minutes more.
Yes, time is very short. Baron, good. Keep it on. It's very good.
What? Move! Faster! Where your glove? Yeah, unless you want to lose your hands. You cannot hear them what is there. What?
如果你这个 meeting 啊，我你看，最亮啊。哇！
I don't know. Two more hours, huh? Social distancing. You want to make the wedding?
This one?
Yeah, this
Yeah, you see,
Yo.
so sexy, you see. I take it off now.
Because we're doing this one first. A lot of solid. Right?
And so how?
MNCL24H. Then therefore. Yeah, just read. That means that. Then how? No, he put me inside. It's not my fault. Because if 4 people too much actually, that's why. MNCL supposed to be MNCL 2 is Thailand should be helping. Oh, helping. What is it?
Oh, the solution. Oh, first we take the solid first. Green. This is spelled green.
That is LE.
Yeah, not yet. Color of solid.
I don't like the feeling.
Oh, because the manganese. Yeah.
That is KMN. What class? It's dark. Should be dark purple, right? Grape or grape purple is NO4 purple. Yeah. Yeah. Deep dark. It's only nickel chloride. NiCl2. We have it. Oh, this is green.
我在 study。
There is purple. Oh, already got. In Korean, it's pata. There is orange. Brown? Orange? I didn't know my connection. CL3. CL3, that means Fe3 plus. Oh, orange. Orange. Hey, it's this here. You can see, right? Like, you can see the background. See clear. Over white paper. I think it's orange to yellow, Fe3 plus. Because when FeCl3, right? FeCl3 means Fe3. So that means it's orange. The seal from matte that is yellow. It's ugly. Oh, ada already. What is that? Macam coklat. What is this? Makan dulu sih benar tu. The color is I think temperature for blue color? COCl2, 2H2O. Blue crystalline solid, the dihydrate is purple and the hexahydrate is pink. Dihydrate is what? Solid ah? Great. COCl2 6H2O. Search for COCl2 6H2O. But it's not blue there. We just wait, this one no. This one is not. Yeah. CO should be CO according to this one say pink COCl2 the purple one. But this one doesn't H2O. That one say what is blue huh? But I think not. You want to put purple or pink? I think according to our observation then later you can put in the discussion. Dark purple dark. Yeah. Then CuSO3 is the blue one tadi. CuSO3. It's
Is it like dark blue? What blue is this? Midnight blue.
Deep blue,
Shahira, let me know if anything wrong or any question you have.
what is this? NiNO3.
You guys doing section 1, right?
Yeah, we are doing section 1.
Okay. So we do section 2. It's level 2 to 1. And then I think we share. Like they do SPM 1 and then over to SPM 2.
We change. Yeah, after we finish the section, you guys finish your experiment. Then you guys do the experiment, then we do apa sih? Green kan? Green right? Should be green. And NiNO3.
Whoa.
This is green. Aqua. I like the color. Picture. Then the MgNO3.
White. Crystal clear. Ish. It's not white lah. Punya more like
White.
clear. Sugar ish. Berani not ada. Pada dia
Eh, this one, the third one is not apa? COCl2 6H4. The third one.
This one lah.
Eternal purple or then just not what like
This one CR. CRSO4.
bukan.
The one ah, I search for is like, I think we can put dark pink.
Oh, dark pink. Oh yeah, huh? Oh yeah, huh? Yeah.
CR apa?
Apa? Salah cari.
This one.
Chromium sulfate. Apa are you using?
Sedap.
Matang ada?
What? Sedap.
Kau tengok? Lepas ni kan tak? Dia
Unknown.
Oh, but the liquid.
Oh, but the liquid is.
Oh, so nice. How is that? I don't know.
What color is this? For me, it's just blue lah.
It looks like green. It looks like
Blue green.
blue green. Greenish blue, bluish green. Apa dah?
Greenish. Jangan.
Guys, don't spend too long on this. Okay. Greenish. Then MnCl2.
This is brown. Wait, no.
This is dirty here. Dirty.
Oh yeah, it's dirty.
I mean,
It's dirty.
dirty from this one.
Is it dirty from the water or dirty from the tube?
I think it's dirty from this one.
So what is it?
Brown.
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 Color solution.
It's dirty, alright. White.
Wait. MnCl2. Should be very pale pink where. Is that pink? The color's not green.
Pale pink ah.
Pink up
Pale pink.
Oh, this so nice.
That is
Dark purple.
KMN. Okay.
Nickel chloride is green.
Green.
Copper sulfate is blue.
CuS.
Soft blue lah. But
Oh, this one you already got.
Serum
yellow.
The anti-purple. Orange one.
Is it orange or yellow? Yellow. Thought it was solid. Oh, this one is pale yellow.
Then just now orange one.
This one more to like orange, that one.
Orange.
So ugly the color. It looks how to say bright. Bright. This one bright yellow. This one.
Dark one.
For me, this is bright. Bright, and then this is light. Oh, this one bright. This one light. Yeah. So FeCl3 is bright yellow.
We put orange one. Because the solid is orange.
Yeah. I just put slash orange. And then K2Cr. Is that O4 or 7? O4. Yellow. Also, even orange. 7A.
Just record down.
Yeah. Don't have to do anything. Pink. Ooh, next one. This one is. Da. NiCl2 is green. NiCl. Already there. Oh yeah, and then this one is clear. MgCl. MgCl. Ini ada MgCl.
And oh, good lah.
MgCl. This is MgCl or MgNO? NO? Do we have MgNO? This one is MgNO. Was this behind this one? Yeah. Oh, that means this one. NiNO3 there. NiNO3. This is NiCl2. Nickel nitrate.
I think this one, right? You see left hand. This one. You see that one miss.
This one and this one. Just not one now. The pink, the photo one is what? Did I put in my here? No, right? You know, I'm very frugal. Are you sure? Wait. This one. MnCl2. Oh, this is MnCl. This is MgCl. Wow. Then this one. This one is KMnO4. Bro, wait, hold on. Hold on. Let me check again. MnCl2, you already have. KMnO4, already got. No. Don't mix. NiCl2, already. CuSO4, ready. FeCl3, ready. K2Cr4, ready. COCl, ready. CuNO3, ready. NiCl2, green, ready. MgCl2. That's MnCl2.
This one. Oh, assume this is this.
Yeah. That means this one is Cr2S. I'm going to show you already. That means we don't have NiNO3. FeSO4. Okay? So I saw FeSO4 now. FeSO4? Oh, that one now. FeSO4 supposed to be Fe2 plus should be
Yang
the solution and nickel nitrate.
Which one the empty one? This one, right?
Ah, yeah, the solid.
What is color?
FeSO4. So, sampai sekarang dia.
I don't know what the solution is.
So we don't have the solution then.
Give it to me, I said.
I think it's we're supposed to do it ourselves. Oh. Then the solution is on it? No. Okay. Now we go to what are they doing?
Everyone has taken the colors.
You can open the one the other day, you know, the room. You can open that also.
Stick it open.
Yeah.
Yeah.
Metal replacement.
So you need, hello, Ainin, you need a bit more of the solution.
What?
You need a bit of more solution there. Otherwise, you will not see any changes. Make sure the metal is dipped inside the solution. Yeah. Hello?
Cái này bác sĩ này không nè.
Yeah, add a bit more solution so that make sure the metal is submerged fully inside the solution. Can you see me?
Yes.
Make sure the metal is fully submerged, is drowned inside.
Okay.
Yeah.
Steamer, right?
What are you doing there, all of you? Jaira, why everyone is gathering there?
Because the chemicals are there.
Oh, Don't let them gather all together at the same place. Ask them to maintain at least some distance.
Okay.
You know, we did the same thing 3 times. So
30 minutes to go. Shahira. 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 Call Shahira.
Sorry?
Call Shahira. Yeah.
I cannot hear what you say.
Shahira. 30 minutes to go. Tell them, remind them that only 30 minutes to go. Have to finish in 30 minutes.
Okay.
And ask them after that to, forgot to tell them that do not discard anything in the sink. Put it in the bottle, yeah?
Okay.
And after the class, make sure they clean everything, yeah?
Okay.
Okay. Yeah, that's it. Thank you.
Okay. 17 more minutes to clean up. Everyone already done this one? Yes. Your group already? This one, number one. This one, already done or not? This one, job done or haven't done? Okay, fast.
We already done.
That's it, done now. Already done this one, right? Let's see you doing it.
Maybe 25 minutes，其实我们有够时间而已。要吗？你要再重新说。Yeah。
Body like. Pink, right?
What?
And solution is whatever you open, you just like believe in yourself. Different operators have different eyes. You didn't know, if it's fish too, the keyword is solution.
Science CYN. This one. This can fly. This two. This can fly.
MGCL.
This two you can fly.
Oh yeah, this one is cool. Yeah, we just put MG and D because it's behind it. We just put
Oh, maybe the color you can fly.
I and O no, MG got this. We just say like okay, but what?
I thought NG.
Like MGCL. Yeah. Correct. What did Erwin say? So MG not train. But don't have right MGCL over here. MG and O3 don't have. Ah yeah, this one don't have.
Ada.
We have the MGCL. Don't have lah. This one don't have lah just now, right?
这是我叫做是可能的还是那种有个在这
Guys, 10 minutes, 10 minutes.
Did you say something, sir?
Yes, I said 10 minutes to go. Are they done already? How many of them has completed or almost finished?
Oh man.
Hello, Shahira. Shahira.
Yeah?
Yeah, how much is them? I mean, what are they doing now?
Oh, they're cleaning up.
Okay, so they are done. Every one of them are done?
Yeah, they're cleaning up.
Okay, all right. Okay, then I'm leaving. So please ask them to make sure everything is there.
Okay.
All right. Okay, bye-bye. Take care, everyone. Bye-bye.
Bye, sir.
Audrey. Yeah, see you tomorrow
When you coming
morning.
to campus?
Next 1st of April.
Okay, sweet, steady.
Thank you. Yeah. Doris,
Okay.
bye-bye.
Huh?
Everyone.
First of April is coming back.
Oh, next week.
See you tomorrow morning.
So it's not where is it now?
Hometown.
Oh,
Bangladesh.
oh, wow.
Bye.
Damn.